Hello, my name is Franck Marchis. I'm a senior researcher at the SETI Institute, and I'm going to talk about asteroid because asteroids are the challenge of the June month. So, what can I say about asteroid in a few minutes? Well, a lot. I'm going to be short and compact, okay? So, asteroids, what are they? An asteroid is anything which is not a planet orbiting around the sun, in summary. So a tiny fragment of rock could be an asteroid, as well as these 1,000-kilometer bodies like Ceres and others are also asteroids. So we find them everywhere. You probably know the most famous one are the near-Earth asteroids. So the name indicates what they are. They orbit nearby the orbit of Earth, and they basically could impact one day our planet. This happened in the past, destroying the civilization of dinosaurs. So it may happen again, destroying the human civilization in the future. So that's the reason we are looking for them, monitoring them, making sure that we can deflect them if one day we detect that one could impact our planet. And then between Mars and Jupiter, we have the asteroid belt. And here we have a million of asteroids already cataloged. So a lot of them, size from a few kilometers to 1,000 kilometers. Ceres is one of them, but there is a lot of them that you probably know by name. Much further away, beyond the orbit of Neptune, we had what we call the trans-Neptunian objects. Those are asteroids which form far away. They're a mixture of ice and rock, and they could be gigantic. Pluto is one of them. Pluto is now what we call a dwarf planet, so it's some kind of asteroid. And then a population a little bit more exotic, it's between Jupiter and Neptune, we have the centaurs. Those are probably dormant comets. We don't really know. The key part here is that asteroids are not boring. We used to call them flying rocks because we thought it was just like some kind of rocks floating in space, but no, they are not like that. They are way more interesting than this. I'm biased, of course, because I study them, but I can give you a few examples. First of all, in 1998, we discovered that asteroids could have moons. They're not flying rocks only. They have mini geological worlds, like mini planets, because I have moons, but also because I have this weird kind of activity on the surface. We know that because we sent spacecraft, or we collected images with these gigantic 8-meter class telescopes, which reveal the presence of craters, weird structures, weird activity, and some of the mission even reveal the presence of salt deposit on the surface, like for Ceres, for instance. We think that Ceres may have still an ocean beneath the crust, an ocean of salty water. We continue studying asteroids because they give us indication on the way planets form, but they also are by themselves very interesting to understand the kind of physics we have in our solar system. But more interestingly, we think that asteroid could be, in the future, a way for us to get material. If one day we become a spacefaring civilization capable of living in space, let's say building space stations and spaceship to travel between planets, we will need some material. So those asteroids, especially some of them which are full of iron, for instance, could be the source of material to build those gigantic space stations in the future. Something more interesting, which has been also mentioned in science fiction book, is that we could use an asteroid itself, modify it to become a spaceship. Let's imagine like we take Cleopatra, which is 200 kilometers in diameter, made of iron. We empty Cleopatra, the inside, and we put some kind of propulsion system that we will have invented in the next 20, 40 years. And we create a spaceship that could fly to our Alpha Centauri. It may take centuries to do that, but we will be living into this gigantic nest cocoon made of an asteroid. A revolution happened also even more recently when we discovered Oumuamua. Oumuamua is not an asteroid, it's an exoasteroid. It's an asteroid coming from another planetary system. There is still some controversy and discussion on the origin of Oumuamua, but it seems to be kind of a fragment of a planet that formed in another planetary system and came to us. The second one that came 2 years ago, called Borisov, had a behavior which is really what we're expecting for an exocomet, an exoplanetary comet. In this case, we have seen by studying Borisov the presence of jets and a coma like we see for any normal comet. So Borisov is probably an exocomet and Oumuamua is probably an exoasteroid. So I hope I kind of summarize in a few minutes what could be interesting to draw to show about asteroid. I mean, there is a lot, so I encourage you to look at the literature and maybe look at our past previous SETI talk, SETI live. We have been talking a lot about asteroid at the SETI Institute because they are fascinating, they are very interesting, and they could be the future of our civilization. So I recommend you have a look on this challenge, and I look forward to seeing what you came out with. Thank you very much. Bye bye.